Welcome, we're going to take a dead FT101E. It did receive, it didn't transmit. I think the tubes were blown as well, but we fixed all of that, a few other problems along the way, and then we put it on the air at the end and get a massive pile-up while live streaming on YouTube. Fantastic, what more could you possibly want? Okay, so we've got the lid off, we're checking the crystals. There's two there that shouldn't be there. What does that mean? I've checked everything off against the list, and there's two crystals that frankly aren't even on the spec, so I don't know what they're for. Okay, so the thing that's confusing me is this one here, which is for 10B, is the same as this one here, which is in the auxiliary port. So they're for the same band, effectively, 30.520. So why are there two of the same? And then we've got a completely random one over here, 24.020, which I have no idea about. Anyway, we know what we've got in the slots now. I will put them all back in where they came from, because assuming it works, then I don't want to break anything. And knowing what crystals you've got in where is quite an important thing, I would have thought, because if we start seeing strange behaviour, we'll know why. Anyway, the crystals are going back in, and we'll just have a quick poke about and see what tubes we've got. So effectively that correlates, so those crystals correlate to the band switch. 80 metres, 40, 20, 15, 10A, where's 10B? I missed, oh, it's straight up. I hadn't even noticed that. 10B, 10C, 10D, 11 probably, time signal and top band. So the time signal, that's, I think you just use that to help with tuning. Now this is the high voltage section, so we're not going to touch anything. Again, this rig has not been powered on for a very long time, so it would have had a chance to drain. Okay, well they both look the same, so that's a good start. It means we've got a pair. And there's a capacitor at the back there, that green thing. Looks to be in okay condition. I think the vertical thing there is a choke. It does look a little bit darkened in the centre, but I don't think that's a problem. Probably just normal wear and tear. Right, so I'm going to power this up. I'm going to put the lid on. I'm not going to put the screws in, but I'll put the lid on and then we'll just switch on some power. It can take a while before it kind of builds up to a point where it goes pop. Let's turn on the heater. So the driver tube's lit up now. I'm not seeing anything coming through from the final section, so I'm not sure if that should light up now or not. So we'll just leave it like that 5 minutes, see if anything goes pop. Okay, I'm going to plug in a 40 metre dipole. This has good SWR across the whole band. So we're in lower side band, 40 metres. Okay, so sit rep. It is receiving, the test tones are coming through in the correct places. However, the receive is super quiet. So we're on 40 metres, I've tuned the pre-select to the high point. RF gain is up, volume is up. I've put in some headphones, super quiet in there as well. We're selecting on internal. Low receive audio is the problem. I've also noticed that the VFO does sort of jump. There we go. See, when I let go, it's moving. That's just dried out grease that's sort of tugging on it as it's turning. You let go and it tugs back. There you go, you can see it there. The fact we've got low receive audio is obviously the biggest concern. I can hear stations and I can hear familiar voices on 40 metres. So we know in terms of frequency, receive, that sort of stuff, alignment potentially is all good. It's just low receive audio. The good thing is none of the knobs are broken, everything's there, nothing's missing. So it's a complete unit. We've just got a couple of gremlins to sort out, which is what you have to expect. So, a couple of issues to fix. Mode selector, sorry, when on LSB it's not working. I have to sort of turn it halfway between LSB and USB for it to work. So we need to clean that up, fix that. Also the VFO, it's got some sticky grease in it. Okay, we're just watching James there on YouTube, he's live at the moment. But I'm fixing my radio, James, sorry. I can't call you because we've got no output power to the finals. Pin 1 and 2 I think it said. Do we have continuity? That should be a dead short. So basically this is a plug. It would serve as a plug if you had another device to connect to this. When you don't have another device, you basically just need to short these two pins. For some reason, I don't know why, I didn't build it, but somebody's cut the wires. Okay. Warm up. Choose. Be certain that the accessory plug is in the accessory socket. The heater voltage to the final tubes is supplied through pins 1 and 2 of the accessory plug. Okay, in we go. The lid's off. We need the bottom off to get to this band switch. Hey presto. Okay. Torch. Alright, this resistor here looks a bit warm. Here. This is the band switch, very complicated switch. Obviously the first thing we'll do is get some contact cleaner and spray in there. I don't have any, so I'm going to have to order some. So by this point, there's a few things I've missed actually because I wasn't running the camera at the time. I'd fixed the accessory plug, I'd bridged that pins 1 and 2, put it back in, powered up, turned on the heaters, left it sat for a couple of minutes, and we started seeing smoke coming out the out the radio. Okay, I've just put a couple of new resistors in this board. Now they're slightly thinner wires than the ones that are in there, but they are rated 1/4 watt. So, yeah, don't know. We'll have to see how we get on. Right, let's get this board in. Okay, plan for today. Fix this rectifier board. There's at least one blown resistor in there. So, if we look at rectifier unit on the sheet, it's R4, carbon composite, 1 watt, 3.3 ohms. So, we have 3.3 ohm. I've got some 5% and 1% resistors. We'll go for the 1% ones. Solder sucker time.
Okay, fine, James. Yeah, the event, the bi-rotor event, the British Inland Waterways on the Air event, is run every year, and it's run, and if you Google bi-rotor 24 or bi-rotor...
Okay, so where are we? I've noticed I didn't really film everything, so I'm having to fill in some gaps. So what had happened, I put the fixed accessory plug in the back, and after I turned it on, I did have the band selector probably halfway between LSB and upper side band. I think that may have been a contributing factor. I suspect a couple of circuits may have been in circuit when there only should have been one either or, you know. So that wasn't a good idea in hindsight, but hey, we live and learn. So that may have been a cause of the failure that I had. Well, this is a trimmer board on the bottom of the radio. This white socket here is the driver tube, so we're underneath the driver tube, and here we have the notorious C13, which is this capacitor here. I think it's 82 picofarad, it's about a kilovolt rating. It needs to be replaced. It's the most likely thing to fail here and cause catastrophic damage to the tubes and the final section. So if you've got this old, I think they call it a domino style capacitor in here, you do need to replace it. You should just replace it regardless of whether it's good or bad, because it will fail eventually, and it will fail as a short which means it's going to cause all sorts of problems. And I'm pretty sure this was failed in this radio, and I suspect this is what caused the problems that I had. Note that this electrolytic here is also looks a bit cracked. It's obviously been very hot. This is a very hot section of the radio under here, and I did replace that. There was a wire, a red wire underneath, and it had melted, and it looked like it was melted to the chassis. I don't know if it was shorting or not, but it was certainly stuck to the chassis and melted. So I fixed that as well. So I cut this electrolytic out, replaced it with a newer one, and I replaced this capacitor here with a slightly different version, because you can't buy these ones anymore. So we'll see in this section of the video what I've put in. Okay, here's the new parts. That's empty. Right, this is the key bit here. These mica 1000 volt 82 picofarad capacitors. Only need one, so I got one spare. That will replace this one here that's completely failing. We'll use the covers that were on the old legs. So before we put this one in, we've actually got another capacitor to put in. So this one here, what's this? 10 microfarad 315 volt capacitor. This is, it reads okay on the tester, but it's, well, I say it's okay, it reads as a capacitor. Let's put that one in. So remember, it's 10 microfarads. It does come back as a roughly 10, I think, but the other specs are way off. It's a big old cap, so it takes a while to test. Right, VLOS 28%, ESR rating 0.1 or 180 ohms, isn't it? So basically that's the VLOS being high, that should be pretty much zero, and ESR should be very low or non-existent as well. So yeah, that's a bad cap, that one. So we're replacing that with a much newer and much smaller in physical size electrolytic. So this one's a 315 volt 10 microfarad, so that's exactly the same as the one here. It's not an axial one, it's a radial leg, so they call this a radial leg. This is on the axis. I think I got that the right way around. So yeah, much smaller, so that needs to go back in where this one came from. We'll pop that on the tester before we put it in. Okay, 1% VLOS, 10 microfarads and 3.2 ohms. So the previous one, remember, was hundreds of ohms. It was 0.150 or something. So the ESR rating, or equivalent series resistance, is a few ohms. So that's good. If it's hundreds or thousands, then you know you've got a bad one. This one's good. Okay, so that cap came out this way, which means this cap needs to go that way. Slightly long. Perfect on that side. And perfect there. So there we go. Legs are covered up. Right, that's that, got it. Bingo! He's not going anywhere. Okay, so under here we've also got a 5-watt resistor. Well, it should be one of these, and that should be here where we've got these 3 other resistors. I forgot, I put 3 other ones in there in their place, but they burnt out. So they need to come out. Right, so that should have been one of these originally, but obviously can't get them anymore. So what we have is it's a wire round resistor through hole, and it's a 1.5k 5-watt resistor. I've got a few of these, as you can tell, and these are not as easy to find. Okay, so this can go back in trimmer board. Right, we'll see how we get on. Let's just pop this bottom back on. Highly optimistic move. Right, I'm going to plug in a resonant antenna just in case. I don't have a dummy load, so I just want to make sure it's seeing 50 ohms. Should it be transmitting? Well, I don't want it to. Okay, right, diligence mode, high power. Don't touch anything, Stu. Note to self. Right, so what I'm going to do is switch it on, see if we get any smoke. Right, tubes are all lighting up. Obviously we're not going to go touching anything inside the radio in this state, very high voltages. Okay, so this is further than I've ever got before. By this point in the past, we've had magic smoke coming out. Okay, welcome. So what we're going to do here now is a cold neutralisation of this radio. In fact, I've already done it, but I'm just recording it again to show you what I've done. So what we've got here, the radio is already tuned up, connected to a dummy load or an antenna. Tune it up in the normal way on 29 megahertz, which is 10C on the band selector. So do your normal things, the plate load and pre-select for maximum output. Then what you do is switch everything off, remove the dummy load or antenna, connect up to your oscilloscope. Now I'm connecting through a adjustable attenuator, and I've got it set at 52 dB attenuation so that I don't blow up my scope, and it's going into this scope here. And what we'll see is when we key up now, bear in mind that the accessory plug is unplugged, so the final tube heaters will not come on. So when I key up now in tune mode with about a carrier of about 6, we will see on the oscilloscope, I want to dip the oscilloscope to minimum. Like I say, I've already done this. Right, we're in. So when I key up, if I turn this variable capacitor the wrong way, you can see the scope's going up. If I go back the other way and go too far, you'll see the scope's going to go back up again. It's going to peak again in amplitude. I want the lowest point. There we go. So I'm keying up, and I've just found the lowest point. That'll do. Job done. So what this does, this prevents, I'm going to switch everything off now. So what I've done is I've adjusted the neutralisation capacitor. It stops the final tubes going into oscillation, which would ultimately destroy them. Golf 5, Sierra Tango Uniform, listening.
Hello, Mike 0, X-ray, Tango.
Okay, a couple calling, and Cal, you were the loudest, and I think you've just fired up. Go ahead.
I've literally just booted, mate, over.
Fantastic. Yeah, it's weird being on 80 metres, Callum. I've not been on here for a couple of years. The first year I was licensed, it was the only band I used, you know. So it's good to get back down here, over.
Tremendous. Are you on the 101 Echo?
Yeah, Roger, 101 Echo, and we've got a Martin & Lynch supplied end-fed half-wave Vibraplex job here today, Cal, over.
Yeah, okay, I'm on the band's iPhone. Hi, SWR, but you're really low in the band. Why aren't you on 3.7 something, mate? Over.
I forgot the band plan. It is the brutal, honest truth, Callum. I couldn't remember what the band plan was ever.
I think you're fine down here, absolutely fine down here. I'm tuned for about 100 kilohertz further up. Alright mate, 5 and 8, 5 and 7.
Yeah, lovely. I've got your 59 here. You're crystal clear, you know, no problems at all. Okay then, mate. Well, have a good weekend and enjoy your stream later, over.
Yeah, I'll bother about an hour. All the best, fella. Bye-bye now.
All the best, thanks. Anybody else? Golf 5, Sierra Tango uniform listening? Okay, Jonathan, thanks for coming in, mate. All the best, 7-3, over.
Yeah, thanks, everybody. Catch you soon.
All the best, thanks. Golf 5, Sierra Tango uniform.
Mike 0.
So that's it, it's back on the air. I'm going to do another video covering all of the tools and test equipment that I used. I was going to put that into this video, but I think that's enough for one video. I'll go back through the oscilloscopes, test equipment, and all the tools that you might need to do basic repairs on these things, similar to what I've done here. Like I said, I'm not claiming to be any kind of expert. This is the first time I've ever fixed a radio, so no claims made whatsoever. If you found this video in any way, shape, entertaining, informative, or otherwise, please consider giving me a like and a subscription as well. And maybe share it somewhere, I don't know, an FT101 users group somewhere, so they can all pick fault with everything I've done. I'd look forward to the comments. Thanks. We'll see you in the next one. Bye-bye.